Okay, today is August 29th. It's almost the end of August, and it's the first day of our third week of school. Okay, we're now fully in school. We're not doing those getting to know you activities as much anymore, and we're actually doing some learning, okay? And so our learning goal for today is kind of similar to last week, right? Our learning goal today is to be able to use exponents to convert metric units of measurement, okay? So we're going to take everything we learned last week about place value, about exponents, and about centimeters, millimeters, and meters to convert metric units of measurement. Now, in the United States of America, we have two ways of measuring things, right? If I want to measure the distance between this side of the table to this side of the table, I could measure it using what? I could use inches or feet, right? Those are called customary units. Or I could use metric units, which is I would use meters or centimeters, okay? So for the purposes of today's lesson, we're just going to be talking about the metric units of measurement. Okay, go ahead and write that down, metric units of measurement. Now, when we're talking about the metric units of measurement, there's three basic units, okay? A meter, and the abbreviation for meter is M. Meter measures distance. Okay, so I could say it is 10 meters from my house to the school because it's measuring the distance from my house to the school. Liter is another basic unit of measurement, and that's measuring volume or capacity. So how much space something takes up. So I might say this water bottle holds 3 liters of water or something, right? Because I can fit 3 liters of water in this water bottle. Okay, go ahead and write that down. Finally, the last basic unit of measurement is a gram. What does a gram weigh? If I say this, what does a gram measure? Itai?
Weight.
Yeah, I could say this thing weighs 3 grams. Right, so if I want to alter these words' meanings, meter, liter, or gram, all I have to do is add a prefix, or it's part of a word that comes before it, and it changes the meaning. So if we look at this chart of prefixes, which you are busy writing in your notebook, we can see that right here in the middle, we have our basic unit. Right there it says meters, liters, and grams. Okay, so go ahead and start in the middle. I know a lot of times we start writing on the left-hand side, but I want you to start in the middle. Now, the reason why I want you to start in the middle is because then you can think, if I'm moving to the left, are the units getting bigger or smaller? They're getting bigger. And if I move to the right from the middle, the units are getting smaller. What does that remind you of? So over here, moving to the left, it gets bigger. And as I move to the right, the units get smaller. Talk to your neighbor. What does that remind you of? What's cool about the metric system is it's set up just like the place value chart. If we have the ones, we can pretend here, I'm going to extend this down like this. We can imagine, and I want you to do this too, this is like the ones place. Okay. If this is the ones place, what would this place be over here? What is this place? The tens. Okay. What about this place here? What would the next one to the left be right here? What place value is this, Michael? Hundreds. And then finally, what's this one right here? Thousands, yeah. How is the value changing as I move from the ones over to the left-hand side? How is the value of those place values changing? Is it getting bigger or smaller? A DT? It's getting bigger, okay. Now, what if I start at the ones and I go towards the right? What would this place value be? The tenths. And you're writing this down, of course. What would this one be right here? Alona? Hundredths, yeah. And then finally, what would this one be? Aaliyah? The thousandths, yeah. And how is the value changing as I start from the ones and I move towards the right? How is the value changing? It's getting smaller. So you can see that that's the same as the metric prefixes, okay? Another way that the metric unit is exactly like the place value chart is it's all related to each other by a power of 10. You can see that we know that there are 10 tens 10 ones in one 10, right? It's the same thing. If I have 10 meters in one decameter, do you see how that works? Or I have 100 meters in one hectometer. Or I have, how many meters would I have in 1 kilometer? If I'm going power of 10, another power of 10, and another power of 10. How many meters are there in 1 kilometer? Michael? 1,000. Another way I can think of that is I can do 10 to the power of 1, 10 to the power of 2, and then 10 to the power of 3. Okay? So in this problem, we're trying to figure out, we know that Alex lives about 15,000 meters away from his grandparents' house, and we're trying to figure out about how many kilometers this is. Write it down, please. Okay? So what important information do we need in order to solve this question or solve this problem? Drew?
So you need to know that since it's 15,000 meters away.
Yeah, we know that he's 15,000 meters away, and we're trying to figure out how many...
How many kilometers?
Yeah, how many kilometers. Good. So to solve this problem, first we need to find the relationship between the units. Okay? So let's take a look. Meters are how many powers of 10 smaller than kilometers. Look at your chart here and figure out meters are how many powers of 10 smaller than kilometers. Show me with your fingers. You're saying 4. Why do you say it's 4? Meters are how many powers of 10 smaller than kilometers? Find on your chart where's kilometers.
Kilometers right here.
And where's meters?
Meters right there.
How many powers of 10 away from each other are they? Count them.
3.
1, 2, 3. Yeah, we can see right here that kilometers are right here and meters are right here. And it's 1, 2, 3 powers of 10 smaller than kilometers. So therefore, if it's 3 powers of 10 smaller, how many meters are there in 1 kilometer? Kevin?
There are 1,000 meters in it.
Yeah, because we know that 10 to the power of 3 is the same as 1,000. So we know that there are 1,000 meters in 1 kilometer. That's step 1. Number 2, we have to figure out, are we going to multiply or divide? Okay? Are we converting from a smaller unit to a bigger unit or a bigger unit to a smaller unit? Think about it. We're converting from meters to kilometers. Are we going from a smaller unit to a bigger unit or a bigger unit to a smaller unit? Talk to your table group and use your place value chart. We're converting from meters to kilometers. So is that from a smaller unit to a bigger unit or a bigger unit to a smaller unit?
Bigger unit to a smaller unit.
Okay, show me about how big 1 meter is with your hands. Everyone, show me about how big 1 meter is with your hands. Okay, now show me how big 1 kilometer is with your hands. How many of these would you need to be 1 kilometer?
1,000.
Yeah. So are we converting from a big unit to an even bigger unit or a biggest unit to a smaller unit? Which one are we doing? Yeah. We're converting from a smaller unit to a bigger unit. So if I have 15,000 meters, would I also have 15,000 kilometers?
No.
Would I have more or less than 15,000?
Less.
Right? So because we're converting from a smaller unit to a bigger unit, we know we're going to have less of the bigger unit, right? So should we multiply or divide? We should divide, okay? So 15,000 meters, and did we say we need to divide or multiply?
Divide.
Yeah, we need to divide it by how many meters are there in 1 kilometer? 1,000. Or, actually, let's write it with the power of 3. 10 to the power of 3. So how does that affect, if we're dividing, how does that affect the decimal point? We need to move it 3 spaces to the 1, 2, 3. So what's the answer? How many kilometers do I have? 15. So Alex's house is?
15 kilometers away from his grandparents.
Okay. When we're changing a smaller unit to a larger unit, you need to divide. When we're going from a larger unit to a smaller unit, we need to do what? Kevin? Multiply. Okay, take a minute to write that down. Just like we talked about last week, the exponent tells you how many times to multiply 10, right? It also ends up telling you how many zeros will be in your product. You can see here, when it was 10 to the power of 1, how many zeros did we have in the answer? 1. When it was 10 to the power of 2, how many zeros did we have in the answer? 2. And when it was 10 to the power of 3, how many zeros did we have in the product? 3. Okay? So we can use this to help us do multiplication in our head. So for example here, I want you to write this down. 7 times 8, that's a basic math fact. 7 times 8 is 56. Now if I have 7 times 8 times 10 to the first power, that's the same as 56 times what? 10. Can we do 56 times 10 in our head? What's 56 times 10?
560.
Yeah, 560. You'll notice the exponent was 1, and how many zeros did we have in the product? 1. Now what if I had 7 times 8 times 10 to the second power? We still know that 7 times 8 is 56, and we know that 10 to the second power is? And how many zeros do we expect there to be in our product? So we can just say it's 56 with 2 zeros. Does that make sense? Now what if we have 7 times 8, which is 56, times 10 to the third, which is?
1,000.
So how many zeros should we have at the end of 56? Yeah, so we can just do 5, 6, and then 3 zeros. Do you see how using exponents is like a shortcut?
Yes.
Yeah. So if you see that, go ahead and try these two on your own, or these 3 problems.